stop us from farming spiders like silkworms and silking out all the super strong fiber that we need.
The problem is, you can throw 1,000 silkworms together and a ton of eucalyptus leaves in there, and they'll happily make silk cocoons for you. If you throw 1,000 spiders together, I guarantee you in 24 hours you'll have one.
Spiders are not team players. They're fiercely territorial, often cannibalistic, bristling with attitude.
Spiders have serious attitudes.
What if you somehow crossed this fearsome predator with a more gregarious animal? Something that Dr. Jeffrey Turner has already done with goats.
Hello, girls. How are you today? This farm is located outside Montreal, Canada. These are very special goats. Within their genetic makeup is one spider silk gene.
In a spider, the gene is responsible for the making of so-called dragline silk, the strongest natural fiber known to science. Dragline is the silk favored for the radii of the web and to suspend from. It's a spider's lifeline. How do you get the gene into the goat? You start with the embryo, or fertilized egg.
What we do is we take a very fine glass pipette and we add just a few copies of the gene into this fertilized goat egg. What happens then, when the goat egg is a single cell, is that the spider silk gene becomes part of one of the chromosomes.
The goats are now part spider. To be precise, they're 1/70,000th spider. It's not like they have 8 legs or anything. But they do produce highly prized dragline silk protein. How do you get the protein out of the goat? You milk it.
The goats produce silk within their mammary gland. Inside their mammary gland is a single spider silk gene, and the goat's genetic information, having this added gene, allows them to produce silk protein in their milk.
Refined out of the milk, the protein yields a syrupy material called spin dope.
This golden solution is very much like you would see inside a spider if you could look inside her silk glands.
Then comes the real challenge, making a super strong fiber out of spin dope. As we've seen, a spider does it by spurting a protein solution through her spinnerets.
And as they line up, then the individual crystalline segments in each of the proteins actually snaps into a lock, just like Legos would. And that actually then binds all the proteins together and occurs very, very rapidly.
Tiny holes in a stainless steel plate become man-made spinnerets.
This mimics or biomimics what is happening in the spider. And as the silk proteins move through the tiny hole, they touch each other, they nucleate, and they form continuous filaments, several miles long, in fact, as long as we'd like to have them.
So far, this is the weakest link in the technology. Artificial spinnerets have only been able to replicate a strand 1/10 the strength of a spider's dragline. The 8-legged web slingers have the advantage, for now.
They've been making silk for 450 million years. We've only had, 10, 15. So we'll catch up. It's just a matter of time.
No spider silk rope just